Welcome to my presentation. In this presentation, we shall explain the formal definition of the derivative of a function f. Consider a curve shown in red here on this graph. If this is the origin O and this is let me extend this a little bit more, and if this is the x-axis and if this is the y-axis, that is the y-axis, and if we were to give some points for the point P and point Q, if we were to project this point onto the x-axis, we'll call this point on the x-axis as x. Similarly, for the or if we were to project the point P onto the y-axis, and we'll call that point as f of x, like that. And for point Q, if we were to project it onto the y-axis, and if we call this point as x plus h, an increment of h, like that. And if we were to project the point Q onto the y-axis, and if we call this point as f of x plus h, the increment in there would be x plus h, like that. Therefore, the coordinate points for P would be x on the x-axis, x ordinate would be x, and the y ordinate would be f of x, and the coordinate points for Q would be x plus h as the x ordinate and f of x plus h for the y ordinate. And if we were to draw a straight line between P and Q, we'll call this straight line as the secant line. As you can see, if we shrink the curve, and if we shrink the curve so small that P coordinates the point Q comes and then joins the point P, then the secant line will be a tangent line. The secant line will be a tangent line. But for now, what we are going to look for here are how do we represent the slope and how do we define the derivative of a function. So to do that, we're going to follow this process here. I'm going to represent the slope, and to represent the slope, we are interested in finding. Let me write the slope here. Slope is defined as lowercase m, and that is defined as change. That is defined as change in the y ordinate divided by change in the x ordinate. Change in the x ordinate. Or we can also define the slope as the rise over the run. Rise will always be vertically, and the run is always going to be horizontally. So in this case, the change in y ordinate is going to be, we're going to take the difference between point P and point Q. This is the change in y ordinate. The change in y ordinate would therefore be f of x plus h minus f of x, like that. And the change in x ordinate would be the difference between these 2 points, and that can be represented as x plus h minus x, like that. So therefore, we can come back and then rewrite this one as the change in y. We have just seen that it is going to be f of x plus h, minus f of x divided by x plus h minus x. We know that if we have since we have positive x and negative x, we can cancel them out, and therefore this simplifies to, this whole thing simplifies to f of x plus h minus f of x, this whole thing divided by h. Okay, as we see here, as x changes from x to x plus h on the x-axis, the function f of x changes from f of x to f of x plus h. Therefore, the change in the y-ordinate or change in the function is going to be the difference between the y-ordinates for the points P and Q, and that is given by f of x plus h minus f of x, like that. And the change in the x-ordinate is given by the difference between the x ordinates for the points P and Q, which is going to be equal to x plus h minus x, like that. So therefore, we have defined the slope, and therefore the slope is this is what is called the difference quotient. Let me write that as well. This is called the difference. This is called the difference quotient. This is called the difference quotient, and therefore we will call this difference quotient as the derivative of x of, or we'll call it as f prime x rather than the slope of the curve. Okay, so this is the formal definition of it. So let me write this here. We will call this difference quotient as the derivative of x or we'll also sometimes refer to this one as f prime x. That means it is the first derivative of x. We will also see higher order derivatives a little later, but this is the formal definition of a derivative. If y is a let me also state this. If y is a function of x, like that, then we can state that f prime x, the first derivative of x, can be written out as the limit of this difference quotient, which is f of x plus h minus f of x, this whole thing divided by h, as x approaches 0. So that is the formal definition of the derivative of x. In my next presentation, we shall see how to find the derivative of a function using limits.